Hi YouTube, this is 133 megahertz. First video of the year. I hope you all had a very good one. This time I'm going to show you something that might be quite cool if you're into old school TV repair. And this is a Universal type TV power supply. What this is kind of like a drop-in replacement TV power supply, like a one-size-fits-all solution. So for example, if you got an old school CRT TV in which the power supply blew up in a spectacular way, so for example you can't find any replacement parts because they're out of production, or simply the power supply design is so crappy that it keeps blowing out after a couple of years, or anything basically that the power supply is dead, you can get one of these. And you can basically disable the internal power supply of the TV and jury wire this up to it and get your TV back up and running. So I'm going to fit this Universal TV power supply into this Panasonic 21-inch CRT TV because this had a massive power supply failure. And let's see how that goes. A few words on the TV itself. This is a Panasonic 21-inch CRT TV stereo set from June 1996. Pretty much run-of-the-mill for its time, nothing really special. This TV was crashed in last year's earthquake. It fell from a quite considerable distance, and basically all the plastic panels and the plastic chassis and stuff, it's all broken. The screw posts don't exist anymore, and there's lots of broken pieces around. Basically the chassis is a long shot, but magically the picture tube is practically perfect. It suffered no damage. The circuit board was cracked from the fall. So this is not mine, by the way. This is from a guy I know from the local retro gaming forum. He brought this to me because he tried to fix it. Tried to repair the plastic as much as he could, but he hit a wall with the electronic part. He tried to repair the cracked circuit board, and while he did, the power supply itself didn't work correctly anymore. The switching transformer was making this loud whining noise, a high-pitched whine, like it was suffering. But otherwise the image was pretty stable, and after a few hours running, the power supply went boom. So he brought it to me to see if I can do something about it. I usually don't take this kind of jobs because the TV is nothing special, and it's really not worth repairing anymore. But this got some sentimental value to him and to the forum, because this was used on the regular meetings the guys had. Where the forum guys meet and they play video games and rows upon rows of tables full of TVs and old school gaming systems. So they really want to see this back up and running, especially when they seen that it actually powered up and the picture tube didn't suffer any damage after all it went. So here it is, and I'm trying to get this back up and running. This TV uses the infamous STK73907 power supply design. This is notorious for being really bad. I've repaired this kind of power supply before. My uncle had this very same TV, and the STK was always a real pain in the ass. The design is really awful in a sense. Panasonic used to issue some aftermarket modifications, because this power supply it's not really stable. It heats up a lot and it blows up after a couple of years. it's really a pain in the ass to repair this. And aside from that, in this case, I suspect the switching transformer had quite a beating with the fall, and probably it's got a cracked core now, and that's why it's whining in operation. Well, before the whole thing blew up anyway. So trying to get the switching transformer alone, chopper transformer, it's probably will cost more than the whole TV is worth. So in that sense, it's not worth repairing this. But with a Universal TV power supply, I could just disable this whole piece of shit power supply and fit this one in its place and get this baby up and running again. And here's the power supply itself. It's made by solder or Suer. Depends on what character they intended to put in here. And as you can expect with all Chinese products, of course you've got some English. TV power switch panel. Is that how they call a switching power supply? Seems so. What else? Well, here's some specifications. Don't know if you can read them or not. Use direction. Well, it says takes an input voltage from 160 to 250 volts. So it's for a 220 volt AC mains country, like here. Here's the output voltage, but it is not complete. It says 110 volts, 25 and 16 volts. There's more voltages than that, as you'll see in a moment. It says it takes up to 25-inch television, so it's gotta be some beefy power output there. Well, here's the supply itself. Pretty basic, your standard switching type power supply from the 21st century. Here's the primary side. There's your fuse, your bridge, full wave bridge rectifier, inductive filter, filter capacitor. So your 220 volts AC, you get them here, this corner, and the other corner here. That's where you hook up your mains voltage. There's no switching here as soon as you hook up the power, it turns on. So in the case of my Panasonic, I have to hook it up after the relay, so it only comes on when you want the TV to be on. What else? Well, it works of a single bipolar transistor. As you can see, the design it's only discrete components. There's no IC chips in here. It's all done discretely. And what else? Well, here's your output stage with all those little capacitors. And here's the output voltages. Here we have 26 volts, 12 volts, 16 volts, 55 volts, 120 volts, and 180 volts. So this practically covers every standard voltage you can find on a TV set, up to 25 inches. 21 incher usually takes the 120 volts as the V plus supply. Bigger sets use the 180 volt. So yeah, as you can see, it's pretty much half wave rectification and filtering, and that's it. Except for the 12 volt line, that's derived from the 16 volt line, and it uses a 7812 linear regulator to get a stable 12 volts out. So yeah, here, before I forget to mention, here's the potentiometer. This is the voltage adjustment for the power supply. This adjusts the voltage, but this adjusts all of the voltages in time, all at the same time. So for example, in my Panasonic, I actually need a 130 volts B plus supply. So what I'm going to do is I'm going to take the 120 volt out, and I'm going to tweak the potentiometer. I'm going to turn it up until I get 130 volts, because you can step up or step down the voltage with this, and all of the voltages change at the same time, because let me flip up the board. You will see here Here's the clear separation between the primary and the secondary, and there's no direct connection between them. There's no the regulation for the power supplies. The PWM is done only on the primary side. There's no voltage sensing on the secondary that goes through an optocoupler. The camera is not focusing, but here's a socket for an optocoupler that hasn't been fitted. So there's no connection between the secondary side and the primary side, aside from the bypass capacitor. So it actually uses a feedback winding. Here's the main switching winding on the primary, and here's a feedback winding used for the discrete circuit to actually regulate the voltage, and the potentiometer is part of the circuit. So yeah, it's something I kind of criticize about the design. No secondary regulation. It all depends on this little potentiometer and the feedback winding. But in practice, it turns out it actually works quite well. The voltage is pretty stable. You know, I haven't tested this without a load, but as a rule of thumb, you shouldn't power up switching power supplies without a load, because it might self-destruct. So what I recommend for this case, before you fit this in the TV, well, at least in my case, I only have a single V plus supply of 130 volts, so I only have to worry about one voltage. All of the others are derived from the flyback transformer. So when you're going to fit this in a TV as a replacement, first you must make sure of the correct value of the V plus voltage, or the voltages you're going to be using. And second, you should get something like a standard 60-watt light bulb, and hook it up to the relevant power output you're going to use. And with using the light bulb as a load, hook the power supply up to the mains, and then start tweaking the potentiometer while you read the output voltage with a multimeter until you get the desired value. So yeah, I don't recommend this doing unloaded, and I certainly don't recommend this doing this with the power supply hooked up already into the TV, because one mistake and you might blow up the rest of the TV. So here's the schematic diagram for the power supply stage of this TV. Here's my AC input, goes to an inductive filter, and here's the 50 Hertz transformer that actually feeds the standby power supply with a standby 5 volts for the microprocessor. So the microprocessor is kept alive at all times, so that it can respond to the remote control on the soft power switch. It activates this transistor that activates this relay that switches the mains voltage to the whole main power supply when you push your power button in the remote control. And so yeah, this is the power supply I have to disable in order to replace it with the universal one. Here's the SDK regulator, and the secondary, we have only one voltage coming out of it, the B plus 130 volts. So that's going to make matters easier for me, just one voltage to replace. So I'm going to plan how I'm going to disable this. And just a quick tip, if you want to repair this power supply in case you stumble in its way, this resistor here and here, this go bad and the whole thing won't start up, because this provides the bias voltage for the regulator. And on the secondary side, here on the voltage sensing that goes to the optocoupler to regulate the voltage, this resistor here, R810, 110 kilo ohm, this goes bad, and the whole voltage reference goes nuts, and the power supply voltage skyrockets and to 200 volts or more and destroys everything basically. So yeah, I'm going to disable this. I'm going to remove the bridge rectifier here, so that would prevent the 300 volts AC from being generated and the whole circuit from being powered up. and after removing the bridge rectifier, I'm going to hook up the AC input of my universal power supply right here on the terminals of the X bridge rectifier, and the AC, so that they get switched by the relay, so that power supply gets switched on just when it needs to, just like the old one on the TV. And on the secondary side, I'm going to remove the whole switching transformer, the chopper, and I'm going to put my 130 volts DC right here before the rectifier diode and the B plus filter capacitor and the avalanche diode, just because it won't hurt actually to have an extra diode in series and an extra filter in parallel. It may actually help a bit with regulation, and I don't like having an inductive component when I'm going to be injecting DC voltage, straight DC voltage on here. So I'm going to remove the switching transformer altogether and get my 130 volts DC here and my ground here, and that should be it. And here's the TV chassis ready for installation. As you can see, I've freed quite a bit of space here on the board. I've removed all the key components from the original switching power supply. Here's the STK switching regulator, the switching transformer, filter capacitor, diode bridge, and some miscellaneous parts. I also put some wires on the power supply. These are my AC voltage in, and these ones are the 130 volts out. So yeah, I think I've freed quite a bit of weight from the board. It's gotta have some relief from all those missing components now. It's not gonna bulge in the middle down so much like before. And fortunately, the power supply seems to fit quite well in here. Nice, almost like it was done like specifically for it. So the only thing I would ever need to is put some screw or some glue down here to fix the power supply so it doesn't move with that TV, and I should be all set. And here's the installed power supply board. As you can see, I've soldered the wires. These two orange wires come from the AC terminals from the former bridge rectifier, just after the switching relay controlled by the microprocessor, so the power supply turns on when you push the power button on the TV, or you push the power button on your remote control. So it works just like before. And here's my 130 volts out, going right to the solder pads on the former switching transformer, just before the fast diode and filter capacitor and the avalanche diode, just to make sure it won't hurt a bit. And so should be ready to go. So I should put this back together and try it out. Okay, so it's time to test it out. The power supply has been fitted. The TV is plugged in, so is the Super Famicom as a test video signal. And here's the moment of truth. Hooray! We get a picture. It works. So let's switch it to video. Perfect! I'm amazed. You know, this thing survived an 8.8 magnitude earthquake. The picture tubes just fine, except from a little misconvergence here on the sides of the picture. Otherwise it's working great, and who am I to complain? The colors are good, the brightness good. You can see the picture is pretty stable, so the power supply is regulating pretty well. It certainly can handle the load of this TV, a 21-inch. Can take the power consumption. This should be good to go. So the only thing left to do, and I'm not going to do that, the owner's going to do it, it's try to restore the plastic case as much as he can, and it should be kind of like new, pretty usable. Okay, so final thought from me. It actually delivers. It does what it's intended to, and it does it well. And for a low price, what else could I ask for? As for the build quality, considering it's a Chinese product from a $10 bottom range, the build quality is not exactly top notch, but it isn't the worst either. I've seen pretty much worse crap coming from China. It's pretty good for what it is. The solder joints and stuff feel pretty well. Pretty easy to use. Everything's marked correctly. Performance, it's really good. After several hours of operation, the heatsink and the transistor, it gets barely warm. And as you may have already seen, the picture quality is great. So the power supply, it's giving a great performance, at least for a 21-inch set. It's pretty good regulation, pretty good filtering. It's as good as the real thing, even better in this case. So yeah, I'm pretty satisfied with it. The TV is working great. The owner is going to be really stoked about it. See the TV working just fine, just like the first day he got it. And well, that's all from me for right now. I hope you enjoyed the video as much as I enjoy repairing these things, and especially when people consider them worthless or hopeless and not repairable. So thanks to you all. I hope you enjoyed. Thanks for watching. And as for that little guy, yeah.